Today, we're going to take a chance to review a little bit of what we've been talking about and add a new skill as it relates to chemical reactions. So we've been practicing double replacement reactions a lot. That is where we have compound plus compound swapping partners. We've seen it on the labs, we've seen it in our notes, we've seen it in our benchmarks. When we have two compounds, strontium chloride and magnesium sulfate, we need to know that we swap our partners. The outside things, the strontium and the sulfate, will go together, and the inside things, the magnesium and the chloride, will go together. But as we put those together, we've got to pay attention to a lot of details. We want to get our names right. Always the metal first, then the nonmetal. So magnesium, then chloride, strontium, then sulfate. And when we write our chemical formulas, we have to pay attention to each formula uniquely. We have to balance our strontiums and our chlorines with the charges from the periodic table. We have to balance the charges of magnesiums and sulfates with the charges from the periodic table. But we have to continue that when we go to the other side as well. So strontium with sulfate may or may not have the same numbers and subscripts on it because we do it based upon the charges that they now have. After all of that, we're ready to balance it. After all of that, we're ready to figure out what's solid and aqueous. So as we pop over to here, we can see this reaction's already done. As promised, we make magnesium chloride and strontium sulfate. It doesn't matter which of those compounds we put first, but it is important once again to write the compounds correctly. Then, because of the charge on strontium and chlorine, magnesium and sulfate, magnesium and chloride, strontium and sulfate, I needed to have a 1:2, 1:1 ratio. I needed to balance each of those. When we're looking at the states of matter, which we won't often do in this format, but we can use our solubility rules, which are given on the back of the periodic table for us. The new type of reaction that we're going to explore today is called a single replacement. The difference with a single replacement compared to a double replacement is that one of our reactants is just an individual element. It is not compound-compound, it is element plus compound. So as I write my reactants on this, I notice that I have something by itself and something that's together. Before we were swapping partners, now in a single replacement, one thing comes in as another gets kicked out. So the aluminum is a metal by itself. Well, it wants to be a part of a compound. So it will come in and it will make aluminum chloride. And unfortunately for itself, the copper is the thing which gets kicked to the metaphorical and chemical curb. So that goes out by itself. But, oops, when we do that, we do have to recognize that our products, although made of the same elements, are going to be put together in a new way. When I was writing copper to chloride, I was paying attention to the fact that copper was +2 and chloride was -1. When I was writing aluminum and chloride, I need to balance those charges by putting 3 chlorines with each aluminum. The elements by themselves, whoa, we got a little crazy there. So I'll see if I can hit and undo. Yikes. We'll just leave that. Sorry about that. When I'm writing the formula of just aluminum or just copper like this, I don't need to put any charges on them. I have now recognized the thing by itself went in, a thing in the compound got kicked out. The aluminum replaces the copper in this because the aluminum is a metal and a copper is a metal. A metal will replace another metal. So just like when we were writing the formulas for strontium sulfate and magnesium chloride, we knew what came first. We can know what our compound can be. Aluminum chloride. So despite the very ugly look to this, we get the idea. A double replacement has 2 compounds in which we swap partners, and a single replacement has one thing by itself sneaking in to kick out one of the other elements.